So hello everyone. So in this lecture I want to discuss two questions, from one question of diffuser and one question from your Ramjet ideal Ramjet engine. So I find this question very interesting. Might be they can ask for 2 marks in your gate exam. So this is just 2 minute solvable question, so might be they can ask this kind of question. So because this question is slightly trickier, might be you can encounter this kind of question, so you will be familiar how to solve those questions. You need not to spend much time in that. Okay, so this question is from your diffuser. Okay, your aircraft diffuser. As of now you just consider it as subsonic. Okay, in propulsion we have specifically subsonic diffuser. Okay, in gas dynamic if you see, you will find out conversion diversion diffuser. Okay, so this is you for your gate 2023. Okay, topic is diffuser. Okay, now let's read the question. Okay, the diffuser of an airplane engine decelerate the flow the airflow from the flight Mach number 0.8 to the compressor inlet Mach number 0.38. Okay, so your inlet Mach number, I am writing as mi, was 0.85, and what did diffuser do? Your diffuser decelerate your velocity or Mach number, and it decelerated to the 0.38. Okay, assume that the specific assume that the ratio of the specific heat is constant and equals to 1.4. What does it mean? They are talking about air, right? If the diffuser pressure recovery ratio is 0.92, then the isentropic efficiency of the diffuser. Okay, good. So they have given what they have given. They have given pressure recovery factor. Okay, which is nothing but 0.92. Okay, okay, let me first okay, isentropic efficiency they are asking. Okay, they have given 4 options. Okay, this is a good question. I will tell you why they have given this. Okay, they have tricked the question slightly. Let me mark first station number so it will not create confusion to you, right? Okay, as of now you just understand this is your compressor, right, which is attached with shaft, and this portion let's mark the station number first. So this is your, I am writing it as a not 1. Okay, and this is not 2, I am writing. You can also write it as a, okay, let's write it as a 1 only. Okay, because entry, at the entry we have static, similarly at the exit we have static properties. We worried about static properties, right? At the entry, at the exit. Inside engine we are worried about your stagnation properties. Okay, so this component your diffuser. Okay, and station inlet is 1 and exit is not 2. Okay, let me correct this also. This is m1. Okay, now they have asked isentropic efficiency of diffuser. Now if you see, there is one formula, P02 divided by P01 1 plus, I hope you have seen this formula. Okay, m1 is square isentropic efficiency of diffuser. Definitely you have to remember this formula. This is 100%, this is very important formula to solve any diffuser problem. Okay, so this is nothing but diffuser formula of isentropic from isentropic relation. Okay, I'm not going to that. I just want to solve this question, and why they have pressure recovery factor they have given, that I want to introduce. Okay, so they are asking isentropic efficiency of diffuser, m1 they have given, right? P02 anyhow they have given in terms of pressure recovery factor, and P1 we don't have. So this is the issue. So what I will do in this, can I do in this way? Please tell me, can I do this in this way? Yes or no? Yes, we can do this in this way. I will tell you what is the benefit of doing this. Okay, and if I solve this gamma minus gamma divided by gamma minus 1 for air 1.4, it is coming out to be 3.5. so I am directly writing it as a 3.5. okay, so if you do this value they have given, okay, which is your pressure recovery factor, this is given, and this we can calculate using simple isentropic relation, because m1 they have given. Okay, m1 they have given, so I can calculate this ratio. How we can calculate? I know this formula to be 1 plus, again isentropic relation for diffuser, m1 square raised to gamma divided by gamma minus 1. You can simply calculate this value because m1 is already given, which is 0.85, which is your inlet Mach number. Okay, and gamma they have given as a 1.4. You can simply solve this p0 1 by p1. As of now I don't have value, I will tell you. Okay, so if you solve this, I am directly writing those values because I have already solved this question. Okay, so yes, okay, yes, if you solve this pressure recovery factor they have given 0.92, and if you solve this from here, you substitute this. I have already solved this, so I am not going into much detail, it will take time then. Okay, it becomes lengthy lecture. So if you solve this way, this is coming out to be 1.145, right? And if you send this ray for 3.5 to left hand side, it will come out to be your 0.285. okay, and this becomes minus 1. Okay, I have already solved this, so need not to do this, and this becomes 0.2 and 0.85, square it. Okay, and I have already solved for isentropic efficiency of diffuser, which is 0.811 is your answer. That means 81%. Okay, so your B option is correct in this way. Okay, so to giving this question, my intent was they can ask in this way also, so my intent was this only, so they can ask in this way. Using that, you have to use this equation also, and you can solve for this. Okay, this is sometimes known as cascade process. Okay, so I will tell you which formula you have to remember. You have to by heart this equation. Please block this formula in your formula sheet, and you should remember this for solving any question of diffuser. So this kind of process you should also know, and this formula for sure. Okay, I hope this thing is clear. Okay, I have one more question of ideal ramjet engine. Let's go for that. Okay, yeah. Okay, so if you see this question, this is slightly on the trickier side, that's why I have taken this. Okay, so let's discuss this also, because this kind of question might be asked for 2 marks again. So please try to solve this. Okay, so okay, ideal ramjet engine, please tell me in comment section why the engine name is given Ramjet engine. Please tell me this. I am giving you the hint, ram pressure rise. Okay, let's read the question. An ideal ramjet is flying at a Mach number m. The exhaust gas static temperature at the outlet of, okay, this is you take it as a nozzle, is TE. Okay, the gas constant is R and specific heat ratio is gamma. Do not vary through the ramjet. Okay, what does it mean? You are considered the ideal ramjet engine, and your gamma will not change throughout the engine. gamma will remain same. Because why they are saying throughout it will remain same, because after combustion your gamma become 1.33, which is your, because after combustion you have gases, right? This is for air. So they are saying don't consider that, you simply consider this throughout your engine. Okay, okay, I hope you understand. Assume that nozzle exhaust static pressure is equals to ambient pressure. What does it mean? They are indicating that you consider please optimum expansion in nozzle exit. Okay, they are saying consider it as optimum expansion, or they are saying need not to consider pressure thrust. Okay, need not to consider pressure thrust. Pressure thrust is gone. Now they are saying and fuel air ratio is this. What is this? Can you tell me? They are saying please neglect your fuel air ratio, which is very small. They are saying please don't consider that, this is very small. They are saying, I will tell you in the solution part, all this thing will make sense, that ideal expansion, optimum expansion, and fuel air ratio is very small, neglect that. I will tell you why, how this will make sense at the solution part. Okay, the thrust per unit mass flow rate is, what does it mean? Thrust per unit mass flow rate is, can you tell me what is this? Now they are saying okay, first let me write the thrust equation, then I will tell you all this thing in the question they have mentioned, that your static pressure is equal to the ambient pressure, what this thing and what is this. Okay, so if you write your thrust equation without any assumption, this is nothing but this Cj minus Ci plus Pe minus Pa into Ae, where your m dot A is a mass flow rate of air, your fuel F is nothing but fuel to air ratio, that means m dot F to m dot A, which is your less than 1 quantity. Okay, Cj is your exit velocity, Ci is your entry velocity or your ramjet velocity, P is nothing but pressure at the exit of the ramjet engine or nozzle, and Pa is the atmospheric pressure. Okay, and A is nothing but Ae is nothing but your exit area of nozzle. Okay, I hope it is clear. Oh, yeah, I hope it is clear. Okay, so let me erase this all. Yes. Okay, now they are saying that you please consider nozzle exhaust static pressure is equals to the ambient pressure. Okay, so that means both are same, so this term is gone. Okay, there is no pressure thrust now, so I am removing this. Now they are saying fuel air ratio is very small, please neglect this, so I am removing these also. So now can you tell me how the equation now look like? Yes, this equation will m dot A Cj minus Ci divided by again m dot A, they have said per unit mass flow rate, so this is gone. Now can you tell me what this quantity is? This quantity is nothing but specific thrust, right? And specific thrust is, now I am telling you the very important note, because many people have a dilemma, and many get previous year solution book which is present in your online shopping store. In that book all the many solutions are they have given wrong. So what they have given, your specific thrust depends on mass flow rate, they have said in that, because but specific thrust is independent of mass flow rate. Can you tell me how? I am telling you that because thrust is given by this and divided by m dot A, so both mass flow rate cancel out each other, so there, so specific thrust is independent of mass flow rate. Okay, so be careful of be careful with all this. Okay, there is some printing mistakes, or they have done some conceptual mistake in that. So your now specific thrust becomes Cj minus Ci. Now they have given 4 options. I need to satisfy from this. So can I write Ci and Cj in terms of Mach number, and because they have given in terms of Mach number and they have given in terms of sonic velocity. Okay, so can I write Cj as m into gamma r Te? Your exit temperature is Te, right? They have given here. And Ci can I write in this way, m, because m inlet Mach number and exit Mach number in ideal Ramjet engine is same. Okay, if you don't know, please go through any of the propulsion book, you will find this. So I can write Cj and Ci in terms of Mach number, in terms of sonic velocity, depending of your corresponding temperature. Okay, so I am writing that now. Fs will be equals to your Mach number into gamma r Te, right, minus again Mach number gamma r Ta, entry temperature. Okay, this is nothing but r. So can I take common your Mach number from this and gamma r from this? I will take that, right? Gamma r, I am taking that. Now at the inside the bracket, this is left out, right? Now what I will do, I will take Ta common, because I need to satisfy this, because at the everywhere this is present. Okay, so there is some mistake, let me tell you, this is nothing but Te. Okay, this is Te only, there is mistake. So now I take common Ta from here. Okay, so this becomes gamma r Ta, and this becomes Te minus Ta under root minus 1. So this is your answer, and option C is correct in this. You can match out. Okay, I hope this kind of question, now if you encounter in your GATE exam, you can easily solve those. Okay, and if you have any doubt, you can definitely ask me in comment section. I will try to answer there. Okay, let's meet in the next video. Thank you.